In this video, we're going to learn how to multiply any number by 11. And most people already know the shortcut for multiplying a one-digit number by 11. If you don't, here it is real quick. 3 times 11. You just duplicate the number 3 2 times. And then 5 times 11 is 55. Okay, well, what about two-digit numbers multiplied by 11? How do we do that? So in order to explore what's happening here, we should probably do it out the long way and see what's going on. So one way you can do this is by taking 35 and multiplying by 11 broken down into 10 plus 1. Then by the distributive property, we have 35 times 10 plus 35 times 1. And this gives us 350 plus 35, which is 385. Now, the way you're probably more used to seeing multiplication is through vertical multiplication. So let's do 35 times 11. So we multiply 5 by 1 and get 5, and then 3 by 1 and get 3. And then most of us have been taught to put a placeholder over here, and we'll talk about it in a second, but what that 0 does and what it represents. But then we're going to multiply the 35 by the 1 in the tens place. So 5 times 1 is 5, and 3 times 1 is 3. Now notice how the numbers that we got here, 35 and 350, are the same ones that we got over here on the left-hand side. And then when we add them, we get 5, and 8, and a 3, so 385, the same thing that we got on the left side. Now what we want to notice here is that the 5 in the singles digit got added with a 0, so it remained a 5. And then in the middle, we have a 3 added to a 5, and we got 8. And notice that the 3 and the 5 are the original digits of the number we were multiplying by 11. And then the 3 in the front got added to nothing, or 0. That is in that spot. So 0 plus 3 is 3. So the point is that the 3 in the front and the 5 at the end are the same digits that we had originally in 35. But in the middle, we have 8, which is the sum of 3 and 5. If we want to do this quickly, what we could do to multiply 35 by 11 is just split up the 3 and the 5, and then in the middle, put the sum of 3 and 5. Now, that's not multiplication. That's just how I'm writing it to show you what's going on. But 3 plus 5 is 8, so 385. That seems like a pretty neat little quick way to get this multiplication done without going through the longer steps. So let's summarize this shortcut we just saw. So multiplying a two-digit number by 11, what we would do is we add the two digits of the original number together and then put that sum between the original digits. So for 42, you split up the 4 and the 2, and in the middle, you put 4 plus 2. So 4, 6, 2. 462 is your answer. Now, 76 times 11, you split up the 7, you split up the 6, and then when you add 7 and 6, you get 13. So what do you think about that? Do you think that's a reasonable answer? Do you think that a number that's close to 100 multiplied by a number that's close to 10 is going to give you something in the 7,000s? Probably not. We're looking at something more like 700 or 800 or something like that. So this number isn't correct. So why did our shortcut fail? Well, if we do it out the long way, we might figure that out. So if we do 76 times 11, we have our 76, and then we put a placeholder and put the 76 again. And we add these. So we get 6, and 7 plus 6 is 13, but we don't write the whole 13 here. We put the 1, and then we add the 1 from the 13, or the 10 from the 13, to the 7 in the next place value. So we actually get 836. 836 should be the right answer. So the correct answer should be 836. You probably saw from this work what actually happened. So you don't actually put the whole 13 here, you only put this 3 here, but then you add this 1 to the 7. So don't just blindly put the sum between the two original digits. So here's a corrected version of the shortcut. So yes, you're going to add the two digits together and put that sum between the original digits. But if the digits add up to more than 9, which means it is a 2-digit number, only put the singles digit in the middle and then add the 1, which represents a 10, to the hundreds digit. So one more time, what we're doing is we're splitting up the 7 and the 6 and adding the 7 and 6 together, getting 13, but we only put the 3 here and we add the 1 to the 7, leading us to 836. Let's practice a few more. So 81 times 11, you add the 8 and the 1, and you put it between the original 8 and 1. So we have 891. Now 28 times 11, split up the 8, add the 2 with the 8, and then place the last 8. But 2 plus 8 is 10. So the 8 will stay, and only the 0 from the 10 will stay, and the extra 1 from the 10 will be added to the 2. So we'll have 308. And finally, 98 times 11, split up the 9, add 9 plus 8, and keep the singles 8. So the 8 stays. 9 plus 8 is 17, so we keep only the 7 and add the 1 to the 9 and put a 10 down. So we get 1078, which is a reasonable value for something close to 100 being multiplied by something close to 10, around 1,000. That sounds good. You can check all of these doing it the long way or with a calculator to make sure that this shortcut is believable for you. So if we have 324 times 11, we're going to have 4 digits for our answer. The 3 and the 4 get split up. And then for the tens place, we're going to add 2 and 4 and get 6. And for the hundreds digit, we're going to add 3 and 2 and get 5. So our answer for 324 times 11 should be 3,564. 567 times 11, again, 4 spaces. We're going to split up the 5 and the 7. Now we're encountering a similar issue to what we had before, where 6 plus 7 is 13, so it's not a single digit anymore. So we have to figure out what to do with that. Could I put the whole 13 right here? Well, that's going to make the number over 5,000 already, and there's still more digits to come here. So that's probably not a good idea. So the 13, only the singles digit will come here, and we're just going to hold the 1 in that place and add it to whatever we get in the next slot. For this slot, we have to do 5 plus 6, which is 11, but we're adding the 1. So we're going to do 5 plus 6, and then add the 1 from before. 11 plus 1 is 12, so we're just going to put the 2 here, and add the 1 to the 5. So actually we get 6,237. So if we could do it with a 3-digit number, we can probably extend the pattern to numbers with more digits than that. So here we have a 5-digit number times 11. As we saw before, the number of digits increases by 1. So we're going to have a 6-digit number for our answer. We're going to have a 6-digit number. We'll start by splitting the first and the last. So the 8 and the 2 are going to stay, unless the 8 gets some spillover from the other numbers in the middle. The tens place is going to be the sum of 9 and 2, which is 11. So we're not going to write the whole 11. We'll just write the 1 from the singles digit and keep the other one over here for the hundreds place. Now the hundreds place is going to be the 7 plus 9. We already see it's going to be too much. 7 plus 9 plus 1 is 17. So we'll only write the 7, carry the 1 over. The hundreds digit is going to be 6 plus 7 with the additional 1 from the previous calculation. So 13 plus 1 is 14. We'll only hold the 4 here, keep the 1 for the next one. The hundreds digit is going to be 8 plus 6 plus the 1 from the previous calculation. We'll get 15. So you write the 5 down and add the 1 to the 10,000s place, which already has an 8. So we finally get 9, 5, 4, 7, 1, 2. 954,712. In the next video, you'll see the reason why this trick for multiplying any number by 11 works. We'll create an algebraic proof for any number with 3 digits and show why the pattern works. And then extend it to any number with any number of digits. I hope you enjoyed this video. See you next time!